So, ladies and gentlemen, our next speaker is an expert whose job consists of literally turning a galaxy of data into actionable knowledge.
Yes, ladies and gentlemen, the gentleman who will be here on stage in a second made the long trip with his wife Angela from Washington to be here with us today, so we get a little glimpse at how much stuff the National Aeronautics and Space Administration, short NASA, is looking at. Ladies and gentlemen, please give a very warm welcome to the Chief Knowledge Architect at NASA, Mr. David Meza.
Hello. Thank you. Good morning, or good afternoon. I'm not sure what time it is just yet. Thank you all for allowing me to be here today. I appreciate the opportunity to speak to you guys. One of the things I want to talk to you today about a little bit is how we do work at NASA. I've heard a lot of the talks this morning, and many of them are talking about the philosophies and what would you do outside of your organization, what's going on in the world and the economy. I'm going to bring it back down to earth a little bit and actually take a look at how we utilize different technologies or different techniques to actually solve problems for our end users. I'm going to talk something about what I call knowledge architecture. And in this situation, I want to show you how you as an organization, whether you're a large organization or a small organization, can use some of these disciplines to actually find solutions for your end users for the problems that they may be having. So, I want to start off, though, with a comment made by Peter Drucker back in 1999. Peter Drucker, if you're not familiar with him, was a leader in the management world, thought leadership, very highly influential in management and in process improvement. And he said back in 1999 that the most important contribution management needs to make in the 21st century is to increase the productivity of the knowledge worker and knowledge work. That was in 1999. Yet, as the surveys as of about 3 years ago, 46% of our workers cannot find information more than half the time. Think about that. In the world of Google, in the world of all these different types of search capabilities we have, 46% of them cannot find that information. 30% of our research and development budget is spent doing work we've already done once before, maybe twice, maybe 3 times before. We're reutilizing we're not reutilizing our work as often as best as we can, and we're wasting our money on doing that. But the one that really bothers me is that 54% of our decisions are made with incomplete or inadequate information. We don't have the data. And when you think about the type of work we do at NASA, that scares me a lot. I'm assuming it also scares you that you don't have that type of information. So what do we do at NASA? And I'm going to go through a few pictures to kind of show you some of the things we're working on, some of the things we do, and then I'll talk a little bit about the technologies and how I do things to try to find those answers from that. I always like starting off with this picture here. This is the greatest photo bomb of all time, at least in my estimation. Back in August 2017, we had the solar eclipse. I don't know if you can see that little black dot running across the sun there. That's the International Space Station, taking a little bit of limelight away from the solar eclipse, cutting across the solar. We were able to capture that International Space Station, go across that to make it one of the greatest photo bombs we've ever had. So what do we do on the International Space Station? We do a lot of work up there. This is a particular Russian astronaut who's actually working within his galley, within his personal environment. As you can see, there's a lot of equipment up on the International Space Station. There's cameras, there's computers. He's actually making a lunch, I believe, in this particular case, in his galley. They've got equipment, they've got his laptop back there, very compact, but they do a lot of work up there in the International Space Station. And we do a lot of research up on the International Space Station. In this particular picture here, we've got an astronaut who's doing some DNA sequencing on the International Space Station. One of the things we do at NASA is that we conduct investigations or experiments up on the International Space Station, and from that we generate thousands of research articles, research reports that get publicized. All that information is passed back to journals that's available to anybody here to look at, but we want to make sure that the humankind has this information to be able to utilize it. But we need to understand, we at NASA need to figure out what's the best way to diffuse that, get that information out to you guys. One of my works in my dissertation is to look at how knowledge is spread across the knowledge economy. And I think I found some ways in some of the things that I'll show you in a little bit on how you might be able to do that within your own organization. But as we get past the International Space Station, we're also starting to look at what we're going to do as we go back to the moon and on to Mars. This is a simulation picture of the Lunar Orbital Platform Gateway that we're looking at building, which is kind of a mini ISS around the moon that helps us to do a platform as we get closer to Mars, a habitat simulation of what we're trying to do on Mars. So that's the kind of work. As you can see, we've got a lot of work going on there that we're trying to do, and we've got over 60 years of data in our organization. But as you can see, we have trouble finding it, from those surveys out there. I'll give you a little quick example of how we couldn't find some information. A couple of years ago, I was talking with an engineer, and he was looking for some information from the Apollo era on an uprighting system. And if you remember any pictures from the Apollo era, when the capsule comes down and lands in the ocean, there's these balloons that inflate, and it keeps the capsule upright so the astronauts don't drown, which is a good thing. When we were working on the Orion spacecraft, which is the next spacecraft going on to Mars, we have a similar uprighting system built into that system. Well, we had a partial failure. A couple of the balloons, and in this particular case, there were 5 balloons. 2 of them did not inflate properly. So the engineers wanted to go back and find information from the Apollo era to see how they did it, so they can reutilize that data to be able to help them. Again, remember the numbers I gave you. 46% of the users can't find the information, and we rework 30% of the time. They spent 3 months trying to find that data. We had it in an antiquated database with very little keyword association with it. I spent hours, weeks actually going through that database, couldn't find the data they were looking for. They went so far as to visit retired engineers that worked during the Apollo era to go talk to them. What did you do? Those engineers went up into their attics, brought down all their old work. Here you go. Take a look at it. Again, they spent amount of time. They were getting ready to do the rework, spend a couple of $1 million in a couple of years to have to redo all this work. This is where they came to me and they said, what can you do for us? Well, introduce you a little bit to what I call knowledge architecture. A platform or a framework that I worked on 3 or 4, 5 years ago now, where I combined 3 different disciplines to be able to look at our data and how we can find these answers. So what you can do from an organizational standpoint is you take a combination of knowledge management, informatics, and data science to find these solutions. And as I break it down for you, knowledge management is a strategy for how you collect, how you identify, how you analyze, and how you visualize that data. That's what you're trying to do. Informatics is the pipeline, the IT infrastructure, the applications that actually transform or transmit that data from one section to the end user. And then the data science are the algorithms and methodologies we use to analyze and transform that data. Most organizations probably have a little bit of all of this, or each of these things. More often than not, they don't talk to each other. What I do with knowledge architecture is make sure they're integrated. Make sure that they work together, that they communicate with each other. And I'll give you a quick example of why that's important. I had 2 people, one in my knowledge management group and one in my IT group, that were trying to work through a solution. My taxonomist within the knowledge management side wanted to get the metadata for a particular set of repositories. The IT guy did not want to give her the metadata. So if we take a look at metadata, the definition of metadata, I went into my taxonomy, give me the definition of metadata, and it's data on the data, information about the data. I said, give me some examples. It's title of the document, the author, where it was created, things that represent the information about a document or the repository she's looking for. I went to the IT guy and said, give me a definition of metadata, had the same definition. I then said, give me some examples. File size. When was it created within the database? What type of file? Is it a binary? Is it a blob? So he was more concerned with the database itself. Same word, same definition, 2 different things. They weren't talking to each other, so that it was lost in the translation across that. Hence where I created this knowledge architecture to make sure these individuals understood across these disciplines to be able to communicate more effectively. Because what happens more often than not, when we set a strategy, the strategy gets thrown over the fence to the IT guys, and they end up giving you a SharePoint site or something like that, and that's not really what you're looking for. So you really need to figure out ways of being able to do that. Now, the data science part of it allows us to be able to analyze that data a little bit better and provide solutions. We can use different types of algorithms. In the unstructured world, we can do things as topic modeling, classification, or categorizing, things that allow us to be able to find that information a lot faster. Going back to the example I gave you a little while ago, utilizing some of these tools and technologies, those engineers were able to find that information that had been spending 3 months looking for within 3 hours after we were able to apply some of these data science techniques onto the data. And we had 62 gigabytes of data they had to look through. So it saved them a lot of time to be able to use it by utilizing this type of a concept. I know this is kind of a high-level version of the concept, but it requires just a little bit of work to be able to look at your data and figure it out. And when you do that, you can do several different things. You got content curation, what we were doing with that information within the Orion and the Apollo system. We were able to look through the data, curate it programmatically, find it a lot faster, and make it available to our end users. Expert finder, search, data-driven visualizations. There's a lot of work we can do. And to give you another quick example of what you can how you can utilize something like this, going back to the astronauts on the International Space Station. Every time they come down from a mission, they get interviewed. They get asked questions. You know, what was the life on the International Space Station like? What was the food like? What was the exercise equipment like? What about the computers? What are all these things different like? They go through hours and hours and hours of being asked these questions, and we capture all of those comments, and we put it into a database, and it gets lost there for years to come. So what happens then is that people may ask the human factors engineers, tell me a little bit about what the astronauts thought about the computer equipment during that time frame. Well, they've got to search through this 90,000 comments that we've got in this database, and it takes them 3 to 4 weeks to go through it, theme it, code it, put it into categories to be able to do that. They came to us, we applied our knowledge architecture framework to it, we did a little bit of analysis, but in this case, some very simple sentiment analysis. In classification, we were able to take what they were doing in 3 weeks down to 3 days. So they're able to get that information and categorize it a lot faster and provide answers back. So we're making the work of the knowledge worker more productive, as Peter Drucker once asked us to do. So real quick, I wanted to go over some of the different things you can do when your tool set, when you're thinking about how to implement this. When I look at it and I think about an issue that's going on in an organization, I break it down into 4 different factors. I break it down into storage. How are you storing your database? How are your data? Where are you storing it at? Think of all the different types of data that's out there. Do you utilize your traditional relational database? Do you go more into a document database or a graph database? Those are things that you have to look at and understand your strategy around how you're going to store it. But in order to, after you store it, then you have to integrate with it. You have to connect it. You have to grab it. You got to think about your APIs, the access to it. How are you going to pull that data out of your storage, and then to be able to analyze it? So how are you going to analyze it? What type of tools are you going to look for in that? You've got different types of open source tools out there, such as R and Python. You can do analysis, or your Koch tools, such as SAS or MATLAB, or even Excel can help you do some analytics, and then if you're on a tight budget. So there's different ways of analyzing it, and eventually from that you can visualize it. And visualization comes in many different aspects. And when you think about visualization, let your data drive how you're going to visualize. Don't try to force a visualization into your data. So if you go backwards on this, the user's looking for an answer. My user is looking for an answer on the Orion operating system. Well, he needs some kind of visualization, some way of seeing that information. But in order to visualize, I have to be able to analyze the data. In order to analyze the data, I have to be able to integrate with that data. In order to integrate that data, I have to know where it's at, where it's stored. So utilizing all of these concepts, you as an organization can easily start thinking about finding solutions for this. And this thing applies not only to NASA, it can apply to any organization from marketing to any other type of consumer type of organization to be able to drive that data, and it can be done from small organizations to large organizations. And one of the last things I wanted to show you is just an image of something we're working on. We had one of our engineers, or one of our interns work on this over the summer on different ways of visualizing data. And these are small little GIFs where we created a graph database of our document repository, and then we're actually using virtual reality where they can fly through there, take a look at these graphs, see the data. As you can see up at the top, right up here, he's flying through, grabbing a piece of data, and actually pulling it up and viewing it. Of course, when you're in there, you've got the whole view of seeing how this data is connected. You can then see the points that it connects to. You can utilize this for IT security. You can utilize this for any types of connections from a graph database. But we're looking at trying to expand upon this to be able to utilize that for augmented reality, maybe even a hologram pulling up on a table where you can see the data and work with it as our users are trying to develop different types of tools or learn about how to work with parts. Because when we eventually get to Mars, when we're looking at times, it's a 20-minute lag between Mars and the Earth in communication. So if an astronaut has a question, he asks a question, it goes to the Earth, it takes 20 minutes and 20 minutes to come back. You know, that's just 40 minutes of time that they've lost trying to find a solution. We have to give them the tools and capabilities that they have all the data there that they can search through and find that information a lot faster by applying these type of visualizations as well as other types of machine learning algorithms. Those are kind of the topics I wanted to touch base really quick on as far as knowledge architecture. I think, again, I believe this is something that any organization can do, but you really have to make sure you integrate them all together. You can't have them separately. You have to make sure that the individuals communicate with each other so you don't get lost in any kind of translation between the different types of disciplines. But if you really use this correctly, I think it can lower your time frame for how users get those answers and their information. And lastly, if I can stick the landing here as my rockets come down to the moon. This is Elon Musk's work, the Dragon X, as they actually come back and do a landing, one of the most beautiful things I've seen in a long time, reusing these rockets. But I've got my contact information in front of it. If anybody's interested, feel free to connect with me. I'll be more than happy to talk. At this point, I think we're good. Thank you.
Thank you.
Thanks, David.
Thank
And
you.
please stay up here.